Hello, everyone. My name is Richard Elliott. I'm the Vice President of Sales for Intelitech. It is my privilege to welcome you today to our webinar to learn how robotics can help students develop 21st century skills. As a quick introduction, for those of you who are not familiar with Intelitech, we have been a pioneer of robotics and STEM-based education for over 30 years, delivering the competencies needed for students to enter and succeed in today's workforce. Our latest innovation, Coder Z, is an online learning environment that gives students the opportunity to program virtual robots using engaging 3D simulations while also meeting key STEM curriculum goals. Coder Z makes robotics accessible, affordable, and enjoyable for all. You can learn more about Coder Z by visiting our website at www.gocoderz.com or by following Coder Z on Facebook and on Twitter. Before we begin the session today, I do want to encourage all participants to submit questions to us throughout the event. We will have some time at the end of the presentation to respond and hopefully have some great discussion. To submit a question, please type it in the chat box in the lower corner of the GoToWebinar control panel. And now, without further delay, I am very proud to introduce you to today's speaker, Mr. Gary Garber. Gary is an instructor of physics at Boston University Academy and is the main coach of the Boston University Robotics team. Gary has led dozens of PD workshops through the Math Science Teachers Association and also through the New England section of the American Association of Physics Teachers, where he also served as president. Gary, the audience is all yours.
Great, thank you, Rich. Do you have my screen? Here we are.
Yes.
Awesome, thank you so much.
There we go. Yes.
Great, well, hey, welcome everyone, good evening. And one question is, why robotics? Well, I just came back from the VEX Robotics World Championship, and there were thousands of kids there, and they all love robots. Robots are cool. It's really the game of the mind. And there were just thousands of kids, and you would have thought it was an NCAA Final Four event because there was just so much excitement and the energy in the air. But that doesn't have to be at a world championship. It could be in your own classroom. I can tell you in my own classroom that when the robots come out, the kids get incredibly excited. Now, how do you make it exciting? You know, just driving the robot around is awesome, and just programming the robot, doing all kinds of things. One, of course, thing you can do with robots is there's an easy way to kind of make it competitive or gamify it. And it doesn't have to be a competition. It could be any kind of challenge, but it's easy to kind of have that Xbox generation of things and gamifying things with robots. And there are so many things to do with robots. It's really just such a wide and diverse skill set, which is what we're going to be talking about today. Whether it's coding or electronics or building or driving, there are so many different things that can be done with robots. The other thing that I like about robots is really there's so many ranges of students it can get to. So really it's great for differentiated learning because you have the very low level where, hey, any kid can just start doing it, whether it's driving it around or putting together a Lego robot. But on the other hand, there's no ceiling. You might have some very advanced things with using a machine shop or PID algorithms. So really just as an entire range of abilities that robotics is open for. And when you're doing robotics in your classroom, maybe you could do it where students are working individually and they each have one or two robots, or they're all working in a large group. You could have, you know, one robot for every 2 or 3 kids, or even one kid, or you could have 40 kids working on one huge robot. So there's so many ways that you can integrate robots into your classroom. And maybe most importantly, robots are cool. So just a little bit about myself. My name's Gary Garber. I've been a physics teacher for over 20 years. Most of this has been at Boston University Academy, which is a high school embedded within Boston University. I've been a very active member for the past several years of the New England section of the American Association of Physics Teachers, where I've given dozens of workshops in computer science, technology, robotics, physics, and aerospace. And of course, I'm also very involved in robots. I've been coaching a FIRST robotics team, which is the large robots, for 18 years now. And I've been involved with VEX Robotics since the very beginning for 10 years. I've been coaching VexIQ for 4 years, and I had just brought my son's 4th grade VexIQ team to the World Championship. I've been doing First Lego League on and off for 10 years and FTC for 4 years. In addition to coaching these teams, I've also hosted dozens of tournaments in the Boston area for all the platforms, Vex, FLL, FTC, VexIQ. I've hosted dozens of workshops. And I also have 2 books out there that you can find on Amazon on Lego EV3 Mindstorms, and I'm actually starting to work on a new book on VexIQ. So what we're going to talk about today is how robotics can help your students develop what I call 21st century skills. So first, I'll have an overview of what I call the relevant 21st century skills, or at least there are many 21st century skills, but the ones relevant to that I think robotics can help you develop. Then I'm going to briefly discuss robotics platforms. Then I'll talk about some of the different processes involved in robotics, whether it's coding or electronics or mechanical. Then I'll talk about some of the different kinds of games and activities that you can do in your classroom. And then, and some of these might be individually based, but then I'll talk about how you can have collaboration and multiple interacting robots. And then I'll kind of finally talk about how to afford this and using materials from different robot competitions for your own classroom. So, 21st century skills. And again, there are many names for it, whether we call it the new learning or 21st century skills. A lot of these ideas I've taken from the new statements from the National Science Teachers Association. One of the things that I think robotics is really great for is helping to develop collaboration and teamwork. And whether you're working in a group of 3 or working in a group of 40. And what's nice is you can have students working on different aspects of the same project or all working on the same little part of it. So you might have a few students doing the mechanical part of the robot, and you might have a few students doing the electrical and the sensors, and a few students doing the coding. And so you can really have a large number of students working on one project. Maybe a few students are doing kind of the entrepreneurship part of it. They're the sales team for your robotics. So really, it's great because one of the things is getting kids to work together and communicate. And how can you have different kids working together? It's very difficult to build a complex robot all by yourself. I mean, yes, one student could do it, but it's a lot more fun when you have several students working on it together. So collaboration and teamwork is really a great way, and robotics can really be great for developing this 21st century skill. Critical thinking and problem solving, or problem-based learning. So there's not necessarily one recipe for how to solve a problem. You give the students a task, build a robot or code a robot, and they can put things together. And so there's all kinds of things they could be doing. And so for critical thinking, the students, how are they going to solve a problem? Are they going to build a low robot, a high robot? What kind of robot are they going to solve? So there's a lot of different ways to solve problems. So critical thinking and 21st century skills. Creativity and innovation. So again, here we have 2 robots built by separate teams at the same school playing the same game. And so what we really have here is one student might build something and then they're innovating on another student's plan. And so working on one student's group and another idea. So really, how many different ways can you solve that same problem? So what's great about robotics is there's no recipe. I mean, yes, you can start low and give the students step-by-step build instructions. But once the students have learned how to use a platform, they can build whatever they can imagine. And then you might look and see what another group is doing in the class, and they might look and get some ideas. Hey, I like that idea. We're going to do something similar to that. And the students can build off of each other and really innovate. And so that's what's another great thing about robotics is I like their idea. I'm going to take their idea, but I'm going to make it better. my sound better now? All right. So another 21st century skill that is really great is documentation. And so again, getting students to really record what they're doing and how they're doing it. And so here we can see some examples of students using documentation. Computational thinking. Again, how do we get kids to come up with a logical sequence of ideas? And so again, first doing one thing, then doing the next thing. And so really getting kids to sequence through an entire series of ideas. Now, one of the most important things when you're engaging in robotics is platform choice. What are you going to use to build your robot? I'm going to back up a little bit here because I think we had just lost that. Okay, yeah, so platform choice. Sorry about that with the audio. I think we got things working again. All right, so what platform are you going to use to build your robot? Again, there's a lot of things that you as the teacher need to consider. What kind of robots are you going to integrate into your classroom? Cost, of course, is very important. You need something that's relatively affordable. Ease of use is incredibly important. So do you want something, depending on, and of course, I get this question all the time at different events. What kind of robotics kit should I use? What do you recommend? And it's always unique depending on who you are and what your situation is. Ease of use is incredibly important. Are your students new to robotics or are they advanced users? Durability is incredibly important. Is this a kit that's going to break after your first usage, or is it going to last for years and years? If you're spending $500 on a kit, you hope it'll last more than 1 year. What's the entry level? Do the students need any coding or building experience, or can they just pick it up? Or are they advanced users already? What's the ceiling for a given platform? And in other words, can they build really advanced robots? Or is it all remote control? Is there any programming even offered with it? How advanced, how big can these robots get? How powerful is the processor on this robot? What are the programming options? If the robot's even programmable, does it have one language that's made by the manufacturer, or are there multiple languages that can go on it? Is it remote control? You might find a lot of robot platforms might have joysticks that go with them. Others you might control with a cell phone or a tablet. When you're looking at different platforms, are there extra parts that you can buy for it? Is it just the one kit, and is that all the manufacturer offers, or are there extra things that you can buy? Now, there's lots of different robot platforms to choose from. The standards, of course, are Lego and Tetrix, VexIQ, Vex, and they've been around for years, and they're not going anywhere. And and there are differences between them. And if anyone has any questions, I'm glad to answer those at the end. But about a month ago, I was at the National Science Teachers Association, and there were dozens of new platforms out there in the exhibit area. I was actually surprised how many Arduino-based Lego-compatible products there are. Now, Arduino's open sourced, and so needless to say, that brings down the cost a lot. Of course, many of these brand new companies, you really do have to ask yourself, will that company be around in 5 years, or maybe even 1 year? what I liked, I just want to mention those Arduino-based Lego compatible products. There were several companies, not just one company, but several companies that I saw there where they take an Arduino board and drill some holes in it, and you can actually mount those little robot parts onto your Lego bricks. So we would call it on mod. And so there's lots of neat things, and they had all kinds of sensors. So there are some really low-cost robotics options out there, much less costly than kind of the standard robotics platforms. Again, with some of these, you yourself as a teacher might have to be a bit more tech savvy, or your students might have to be a bit more tech savvy to use them. Again, there's a lot of great stuff out there on the market. So, what are the different processes involved in building a robot? Oh, after you give your students the problem, the first thing, of course, is the brainstorming stage. The students have to work through all their ideas, and this is where the collaboration really comes in. You might have the students working in small groups of 2 or 3 across your entire classroom. All right, you've given them the problem. What kind of solutions are we going to come up with? And one group or individual will come up with an idea, and somebody else in the class will say, I like that idea. What if we changed it a little bit and added onto it? This is where the collaboration and the innovation comes in. So the brainstorming stage is really critical. And your job as the teacher in this brainstorming stage is to facilitate and make sure that every voice gets heard. Because the best problems are ones where there isn't one solution, and there are multiple solutions to that problem. And so really, you do want all kinds of solutions. Now, another major process for this, of course, is the electrical. Now, most robots have a variety of sensors, and it might be measuring how much the motors turns, it might be gyroscopes, it might be color sensors, it might be ultrasonic sensors. But really, a major thing, and you might have a couple kids working on, is, all right, how are we going to use sensor feedback to control the robot? A robot doesn't see things, it doesn't hear things, but we call them sensors, just like we have eyes and ears. It sees numbers. It might be a touch sensor with a value of 0 and 1, or it might be an ultrasonic sensor, which gives you a distance of how far you are from something. So the students have to decide, how are we going to control our robot using sensor feedback? How is the robot going to use its senses? And that's a large part of what we call systems engineering. Another large part of it is actually building and putting your robot together. And again, the simplest thing to start out with is just simple pencil sketches. Getting kids to draw what they think their robot is going to be like. And then, if you have the facilities and the more advanced students, they might use computer-aided design to put their parts together. What I like about this is something that the kids can do for homework or at home. You can have them work together, but send them home. Their homework tonight is draw a picture of what you think your robot's going to be. Or if they have access to any of the online CAD programs and they have the internet at home, they could do that too. So again, this kind of design process is critically important. And getting things, yes, kids could just throw together a bunch of Lego pieces or what have you, but getting kids to really think through the design before they do that's really critically important. At the start, they might need to learn how the pieces can actually get put together, and step-by-step instructions are useful for when you start out with robotics. But as the kids get more comfortable with whatever medium you're using, getting kids really into think about the design, the mechanical design, is critically important. Coding is critically important. So again, not every robotics platform involves coding, but having a robotics platform that does coding is pretty key. Now, there's a lot of text-based programs out there. Depending on the age of the student, I like the visual programming languages, whether you're talking about Scratch or you're talking about Blockly. And I'll tell you, you might think, oh, well, advanced students won't be interested in the visual programming. I've used visual programming languages, all the way from 2nd grade all the way up to university students. And so really, particularly if students are new to programming, there's nothing wrong with the visual programming. Now, one of the most things that I like to have is, if it's available, having a kind of a simulator to run your code on. Because you might have a couple kids who are developing code for their robot, where you have other kids in the class who are actually building the mechanical of the robot. The one problem you might often have is, well, the kids who are coding can't test out their code because the robot isn't finished yet. But if you adopt a robotics platform that actually has a simulator that the coding kids can test their programs on, then hey, they don't get bored and they can test out things too. So what's neat is, just like the mechanical people can build something and iterate and let them fail and fail forward, same thing with the coders. They can develop something and let it fail and move on forward. Personally, I like to use Coder Z because it has a great physics engine. There's a lot of reality behind the simulator. But there's a lot of great products out there on the market. And again, as I just mentioned, testing and redesign. What maybe one of the most important things for that robot to do is to fail. You want the kids to try it out and see what goes wrong. One of the problems is kids are so scared that they need to succeed and they need to get the right answer. But if they're always getting the right answer, they'll never come up with any new ideas. You want them to fail forward. You want them to figure out what's wrong and redesign and innovate and change their ideas. So it's really one of the best things is try it out, figure out what works, and give them plenty of opportunities to redesign and rebuild their robots. It's so critical. Otherwise, if it's just wrong answer, move on, the kids will never learn that failure is okay, and that's where they're going to be learning from. Another important part, whether we're talking about a robotics competition or whether we're talking about in your own classroom, is communication and entrepreneurship. Every company has a marketing team that needs to sell that product. You can build the best widget in the entire world, but if you can't sell that widget, your company is going to go out of business. So really, some of the kids might be more interested in the marketing and the entrepreneurship and developing a business plan and communicating why is their idea great? What is so special about their robot? And this is where you can involve other adults in your building and have other adults come in to be evaluators or possible customers for the robot that they are building. And they might be the clients. I need a robot that does this. And so this is kind of a great idea of really, they can build a robot. At the end of building it, it's going to be a showcase, and they have to sell their robot and market it to several of the other teachers or administrators in your building. This is also a great way to get those administrators into your classroom so they know what's going on. Or even in your local town newspaper, and then have the journalists come in and then talk to the students. The kids will need practice talking to adults before they talk to your local journalist. Again, this is great lifelong experiences for the students. Now, there's a lot of things that you can do in the classroom. I mentioned earlier at the top of the hour, gamifying the entire thing. Now, one of my favorite little games to start out with is make a big circle and put a pile of candy in the center, and the kids have to build a robot to grab the candy. If you look in this picture here, we have several Lego robots, and look how different each of those robots in that circle look. We have a variety of them, and a lot of them, usually the strategies, get to the circle as fast as you can or be the strongest. Some of the kids might use sensors to try and detect, is there another, did they reach the candy, or is there another robot there? There might be some strategies. Great story is, I had several of these robots try it, and they all went to the center of the circle really, really fast. But then one of these robots just sat there after the kid had pushed the button, and it sat there for 30 seconds. That kid thought, everyone's going to try to get to the center quickly, and they're all going to smash into each other. And then they're going to drift off. So I'll just wait for all the other robots to clear out, and then I'll come in and get the candy at the end. And you know what happened? That's the kid who won. All the others battled it out, and they deflected off each other, and none of them got any candy, which is usually what happens, except for the one kid whose robot sat there for 60 seconds and then came in with a bulldozer and scooped up the candy at the end. That was, and again, we're talking about third and fourth graders who came up with this. But I've done the same activity with adults and college students. And again, it's almost always the same. Now, because of BattleBots on TV, the kids, of course, want to build those Rockem Sockem robots that knock each other down. And again, that's a lot of fun. And you can do that with joystick, or you can do it fully programmed. Another version of that is the spot where two robots have to push each other out of the circle. Is interesting. Another great little story about this is, again, in this very class that we're looking at here, is most of the kids, when they started out, these were fully autonomous, and they just built little spinny things that would spin around and knock the other robot down. One of the kids figured out, well, gee, they're always spinning the entire direction. And this was a third grader who did this. So what he did is he took a random number generator. So sometimes his robot spun around clockwise, and sometimes his robot spun around counterclockwise. And because he could get his robot to randomly change directions, his is the robot that won the game. I mean, for a third grader to think, gee, is there a way to control it randomly? I was really impressed. Now, some of the greatest things to do for games involve mazes. And to make a maze, all you need are a bunch of 2x4s or even some electrical tape, and getting the kids to use some kind of sensor feedback to navigate through a maze. And it's great to do that autonomously. These are great games to play. What I like about using 2x4s to make a maze is, yeah, you can get the kids to solve the maze one way, but then you can just rearrange all those 2x4s and make a new maze. All right, you solved one maze. Let's make a new maze and see if you can solve this new solution. Can your robot solve no matter what it comes up against? Which is part of the goal of autonomous cars. It's one thing if you can drive to A to B, but what if you have to change the route? So again, you get into some really advanced thinking with these kinds of games. Now, you might have 2 or 3 students working on a single robot, but some of the best stuff you can do are these classroom-wide exercises where you involve multiple robots. One of my favorite, of course, is kind of a Rube Goldberg type device, where each group of 2 or 3 students has to build one robot that has to, let's say, pass a ball to the next robot. And it could be a tennis ball, it could be a little Lego ball. And this way you can involve every little group in your class. It's very difficult. They have to figure out, I have to pass it on, I have to get it to the next person, I have to receive it, what kind of sensors am I going to use? And so this is a great class-wide activity. Other great things are kind of the Google car activity. Now, one common thing to teach with robotics is line tracking. And line tracking is pretty easy, but what if it's a big line and you have several robots on that same line? How do you maintain a safe driving distance? Now, that's a little abstract for the kids, particularly if they don't drive yet. But what they might be familiar with are ducks walking and following the mother duck. And so you could have one mother robot and all the little ducklings following that mother robot. So there are lots of ways to involve multiple robots. There's an entire branch called swarm theory where you have lots of robots searching for something and they're all interacting with each other. Or you could have your robots playing kind of a robo-soccer game, all trying to get into the same thing. Needless to say, multiple robots are used in lots of competitions, such as VEX IQ or VEX or FIRST or BotBall. So a lot of the time you'll have multiple robots on the field at the same time. And this is, again, a great exercise in collaboration. Now, one nice thing is, these are extracurricular activities. They're outside of the classroom kinds of things. But that doesn't mean you can't buy those materials for your classroom. So the people who come up with these games, these game committees for these international competitions, needless to say, they've put a lot of thought into these games. And after the season's over, there's a lot of surplus game materials. And you can use these games in your own classroom. One of the most common and famous example, of course, is First Lego League. And again, First Lego League itself, it uses Lego Mindstorms robots. The playing field, it is on a 4 foot by 8 foot table. And what's great is there are all these tiny little missions made of Lego bricks. And all these, sometimes the kids have to track lines, sometimes they have to push things. There's all kinds of cool things in this First Lego League table. And here in the picture, you can see all these little manipulables. One thing about First Lego League, it's kind of a short season. Usually it starts in September and it's over by January or so. And so you can purchase used First Lego League field kits at the end of the season, and it varies by state by state. But even if you don't use the actual Lego bricks, the mats themselves have lots of great lines that you can use for line tracking in your classroom. And there's dozens of mission models that you can use, all made, of course, of Legos. Now, the original price of these is $75, and sometimes Lego even sells them. Now, this is a bargain because you get about 3,000 bricks, and a Lego kit like that, if you were to buy it in the store, would probably cost about $300. Just to let you know, the kind of the resale market on eBay, it's hugely overpriced. Those $75 kits, you might be seeing those go up to $300. So where do you get them from? Look around and find out where the nearest First Lego League tournament is, and then go and offer to buy some of the kits off the tournament director. I can tell you at the end of my tournaments, usually we sell our kits because, you know, you might buy 6 of these kits, and maybe the first year or two you keep them, but after that, I've got more than enough Legos, and you're just trying to get rid of these things. So go to your First Lego League tournament host and say, hey, can I buy one of your kits at the end of the season? And they will be probably glad to get rid of it, or they might even give it to you. Now, once you get it in the classroom, you don't have to follow the original game rules. You can make up your own games, or you can make up your own missions. Or if you have these little buildings, or sometimes you have to push things, sometimes you have to flip a lever, sometimes you have to spin things, you can combine little missions from different years. And they get stuck down on these mats with some Velcro. And there's all kinds of things you can do for teaching things. There's color sensing and moving the objects around and line tracking. So really using these First Lego League kits in your classroom is a great idea. So that's what I wanted to say for now. I think now I will open up the floor for questions.
Well, thank you very much, Gary. Great job. While we respond to a few questions we received here, I do just want to encourage anyone else to continue to post any questions you may have. If we do not get to answer any of your questions live or don't have time to go through the more detail, we will make sure to deliver them to you as soon as possible. So, Gary, our first question comes from someone local for us, a participant who is from New Hampshire. They're looking for any suggestions or recommendations we may have for any workshops or professional development coming up soon. And so before I hand it back to you to answer, I'd like to just say that we occasionally offer local workshops and professional development at our headquarters at Intelitech in Derry, New Hampshire. So I will certainly share the schedule of our upcoming offering with you. But Gary would love to hear if you may have any recommendations or may know of any local sessions for our local listeners.
Yeah, so beyond the fine stuff that Coder-Z offers, if I were to say, in my opinion, some of the best stuff that's offered, at least on this side of the Massachusetts border, is at the Tufts University Center for Engineering and Education Outreach. And you can either look there, or you could go to legoengineering.com. And they just offer amazing workshops for teachers and students. What I will say about the stuff that they offer, it's just not somebody throwing together a workshop. Most of them are underwritten by the National Science Foundation and based on genuine and proven research methods. So they try out an idea and they observe it and they take data. And so really it's tried and practiced things. So, and a lot of people actually do come from out of town for these workshops, and that's just north of Boston. And so, if there's anything, actually people do come from all over the country for those workshops. And so again, that's the Tufts University Center for Engineering and Education Outreach.
Wonderful, thank you, Gary. I do have another question in this regard as well. This person is a biology teacher at Early College, and they're curious of the local possibilities if you know any there.
So you're a biology teacher, and it was the possibilities of, what was that again? Or repeat the question, please.
I'm sorry, Gary, they were just wondering if any possibilities local to early college. And then I also had another question, if you could share the name of the Tufts University program again.
Yeah, so the Tufts University program is the Center for Engineering and Education Outreach. Now, if we're looking for biology and robotics, if that's what I was interpret was the correct thing. You know, when I think about it, you know, there's certain undersea robotics stuff that's done, and there's an entire kind of submersible robotics competition that's out there. I know there's a lot of stuff that's out of MIT with chemistry and Legos and building chemistry models using Legos. When it comes to biology and robotics, I mean, the first thing that kind of comes to my mind is there's a lot of activities of building an animal out of Lego robotics kits, and what kind of senses is it going to have, and how to make that an interactive animal. So not just something that kind of walks around and makes noises, but something that has sensors and is going to interact with the environment. And these are really kind of great things. So the kids might be researching, or how does your animal work? And how are they going to build a model of that animal using their robotics kit? I'm not sure if that was the question, but if not, just clarify. I'll be glad to elaborate more. And kind of curious, how are robots used in biology? And you know, I can say, you know, in many ways, particularly in observational tools, or you know, and kind of like undersea exploration, and it kind of slowly exploring different habitats. You know, the other thing I think I'll generally say is, again, modeling robotics behavior. You know, if you Google big dog or little dog, there's some great examples of modeling robotics behavior with robots. And again, I can go a lot more into animals and like how they're using drones for things, but I'll let clarification.
Thank you, Gary. No, that was very helpful. I did get a couple other questions as well in this regard too. I think the staple here is just, you know, other ideas or thoughts on how to involve more than just physics into robotics. I know you kind of answered part of that already, but I think that's what some folks are curious about too.
Oh yeah. So again, you know, so I mean, one of the great things. Okay, so about so you know, and this gets into sometimes when people ask me, what do I like for robotics platforms? And I can say, in my own classroom, I use Lego Mindstorms, whereas after school, I tend to use Vex or Vex IQ a bit more. And one of the reasons in my own classroom I like the Lego EV3 is because of the sensors available to those Lego kits. And what's great is, you know, people think Lego robotics, and they probably think, all right, you've got a motion sensor, or you've got a gyroscope sensor, or a color sensor. But what's neat is there are these adapters sold by Vernier Software, and for like, I think it's about a $15 or $20 piece, you can plug in any of the hundreds of sensors that Vernier sells, whether it's a heart rate sensor, or a pH sensor, or a gas pressure sensor, and you can plug in and actually take data with your Lego robot from just about any kind of sensor available, and use that as a data collection system. So there's a lot of great stuff for using all kinds of sensors. And what's neat is the Lego software actually has graphing capabilities. And so you could, you know, all right, what's the wind speed over time, or heart rate over time? And so there's lots of kind of neat things that you can do in your classroom if you're going to use more sensors, and it's kind of commonly available.
Wonderful. Thank you, Gary. I do have another question here. I do have someone who's teaching gifted education in South Alabama, looking if you were curious of any professional development in this area. They do have EV3 kits. Just curious if you have any ideas there. If not, I figure we could do some research and get back to them.
I mean, well, part of the nice thing about robotics is, like I said, there's no ceiling. And so maybe you're going to start out with, and again, this is where the professional development stuff that they offer at Tufts is really great, is because you can get it on several levels, and maybe you're using the actual software that comes, let's say, with the Lego EV3 kits, or maybe you're using LabVIEW, which is necessarily quite a bit more advanced, or maybe you're using Blockly, maybe they're using Java or Legos to program their Lego robot. And again, that's a great example of where Coder Z is useful, is because it can start out with Blockly, but then you can easily bump it up to Java and Legos. Now, what's great is if you've got those really advanced kids, yes, you can start out with, all right, making the move forward and turns and use a little bit of sensor feedback. But you can get into really advanced stuff, or what's called proportional controllers, or what's called PID, proportional integral derivative controllers. And again, it's a typical undergraduate experiment to use PID control, but I've worked with plenty of fourth and fifth graders and had them writing and creating PID loops on controllers. There's nothing all that hard. It's very abstract, and but kids can do these kinds of things and get into really advanced coding topics where they're talking about derivatives and integrals and making their robots that will use that kind of mathematics to control their robots. Again, PD wise, check out Tufts, and again, we can probably get you some other links that are related to that.
Wonderful, Gary. Thank you. I do have another question here. Someone's asking if there's any curriculum for learning for someone new to coaching and teaching robotics. There was mention of Code.org, Code Academy, other free online resources, but looking for recommendations on anyone who could begin their learning, either covered in one of your books or anything else you may recommend.
Great. Yeah. So the Tufts University site is legoengineering.com. And you mentioned a couple books that I have. So what you'll find is, the two books I have are Lego-based books. I'm coming out with a Vex IQ book this summer. And a lot of the stuff that's out there from the manufacturers, what you'll find is they kind of give you a very low-level introduction. These are what the different commands are. They don't really tell you much how to put something together. And then they might give you, this is like the super awesome thing that you can build. And so they kind of give you the very low end and the very high end, and not kind of like all that, all right, how do you get from low to high? And so what I will say is, again, the book that I have on the market, Learning Lego Mindstorms, just Google my name with Lego and Robot on Amazon, and you can find it, is I try to bridge that gap between the very low and getting yourself to an advanced stage. And so, I'm going to assume that, hey, you can read the very basic tutorials from the manufacturer, which really just describes the blocks and how do you synthesize all those things together. And for what it's worth, there is a print version of my book, and there's a digital version of the book, and being quite frank, don't buy the print version. Only buy the digital version, because with the digital you can zoom in and see the pictures and it's in color, whereas the print version is in black and white and you cannot zoom in. Next.
Excellent. Thanks, Gary. I do have a great question here. Someone asking, how can you use the Lego EV3 along with Vex or Tetrix, and what more can you do when you actually combine two systems?
Yeah, so so you've got these Tetrix pieces, and there's another one called Matrix. So with Tetrix, which is a product which is sold by Pittsco, which is out of Kansas, and they have these little adapter pieces where you can basically mount or connect your Lego bricks to these metal pieces. Now, so that's one option. This other option is there's a new platform, and I don't think they sell too many of these in stores. It's called Matrix, and Matrix is out of China. And again, the space, and again, these are metal erector set style pieces, but the metal pieces are in the Lego world what we call on mod. In other words, the spacing between the holes line up with all the holes in a Lego brick. Now, before you jump into that, what I'm going to suggest is go to the National Science Teachers Association website and go to the list and go to this year's past meeting, which was about a month ago in Los Angeles, and look up the list of exhibitors. And you will find, I think, about 4 or 5 different exhibits of people who are selling Lego compatible kits. And there are all kinds of, again, you can buy Lego bricks at any yard sale. But these were pieces that, again, some of them were Arduino based, but some of them were sensors. And again, you can match all kinds of pieces to your Lego bricks, which is kind of interesting. And when it comes to, like the VEX IQ versus the Lego, I did a webinar, I think a couple years ago, that if you Google EV3 versus VEX IQ, I actually did kind of a webinar comparing sensor feedback in the 2 platforms. And you can find that online. It's on the O'Reilly website, kind of detailing, all right, who has the better sensors and the better bricks. It gives a bunch of details on that. The 2 systems themselves are not necessarily compatible. Next.
Wonderful. Thank you, Gary. I did have another follow-up question on the names of your books again.
Right. And so actually I'll scroll back to what I will do is I will scroll back to the beginning here. And so the longer, so there's one book that's called kind of, I think, Lego Mindstorms EV3, but the better book, in truth, in my opinion, is Learning Lego Mindstorms EV3. And you can get it on Amazon or O'Reilly or the Barnes & Noble website, or you can get it direct from the publisher, which is out of London, called Pact. And again, like I said, I advise getting the digital version as opposed to the print version. If you buy the print version, directly from Pact, you'll get a free digital download. If you buy the print version from Amazon, technically you get a free digital download, but there's some hurdles.
Great, thank you, Gary. I did have a couple of questions regarding more teacher-oriented support. I had a few folks who were asking any thoughts or advice on how to best troubleshoot robots, if it doesn't pick up a certain part, or if you're trying to teach students how to turn a specific way. I did have a couple folks ask some questions on looking at other resources, whether it's free or things like your book or Coder Z, but just a bunch of people looking to teach robots and looking if you had any advice on any kind of troubleshooting type of support.
So when it comes to, let's say, actually accomplishing missions and solving the problems that you pose to the kids, they'll figure it out. Where you as the teacher might be most useful is probably more in the, let's say it needs a firmware update, or let's say the screen freezes up, and making sure the batteries are charged. And so your support isn't, the kids will come up with their own solution to things, so you don't have to worry too much about that. But when it comes, and again, this is where the collaboration piece is really great. Is, let's say the kids have a problem and the robot isn't performing exactly the way they want it to. Again, this is where you want to bring discussion into your classroom, is have the kids discussing it. All right, this is what's happening. And hey, if that one group of kids can't solve the problem, some other group in the classroom will probably figure it out. And then you make it into a classroom exercise. All right, here's this problem. It's not behaving the way it should. How can we solve this problem? Another great book out there, if I recommend another book, is by a guy from Australia by the name of Damien Key. And I believe the title of his book is, it's something like Robotics for the Busy Teacher. And I might not have the title exactly correct, but his name is Damien, D-A-M-I-A-N Key, and I think his last name is Kee. And again, that's really a great book that I highly recommend. So it's classroom activities for the busy teacher. A good question, what are the differences between WeDos and EV3? And so WeDo is an effort to bring coding down to kind of the kindergarten through second grade. And there's a lot of thoughts on this. I know some ideas are to get coding as young as possible. And and this is a personal opinion, that down in the kindergarten, first grade, second grade, truth is, I mean, yes, you can, the WeDo does make kind of coding accessible to those younger ages. I personally like to emphasize the mechanical things with kindergarten, first and second grade, and just putting things together. Now, mind you, that doesn't mean it can't be motorized. So, for instance, you could use the WeDo, the motors, but you don't have to use that. Lego also sells what are called these PowerWorks motors that they use with kind of like their advanced technique kits, TECHNIC, the things that the teenagers play with. But all you need is a battery pack and the motors, and then you just let the kids build things. And so, again, this is personal, but really those younger kids, I like to let them focus on more the building of things rather than kind of the clicking and drag and putting a computer screen in front of them as young as possible. Another interesting thing, it's some people have done it with Lego, but there's a couple platforms out there where the kids can actually write lines of code by taking blocks. And I forget the name of the platform now. It was developed by Marina Bears over at Tufts University also, where the kids take colored blocks and create lines of code using blocks. And so we're talking like wooden blocks. And a green block would mean go, and a red block would mean stop, and a purple block would mean do a wiggle, and an orange block means do a U-turn. And so the kids line up these wooden blocks to try and develop code that way. And again, maybe it's, I'm just thinking we're getting screens in front of kids a little bit too young. But again, I'm sure there are plenty of people that would argue that with me. Again, the WeDos are more for the kindergarten through maybe third grade at most. The EV3, you could use them as low as second grade. The programming gets a little harder with the second graders. Third graders, no problem. Fourth graders, easy. But again, those younger kids, I'm gonna say, WeDo is nice, and so if you really want to get the coding for the younger kids, the WeDo is a better option than the EV3 with kindergarten, first and second grade.
Great, thank you, Gary. I think we have time for one more question, so I'll ask that here. If anyone else wants to submit additional questions here in the next few minutes, if we do not get a chance to have time to do this on this webinar, we'll make sure to follow up with you individually on email. But Gary, someone asking for some recommendations on what platform you think might be best for middle school, and they're curious if you've seen a lot of success with Arduino, curious if that level of coding may be too hard for them. This person would love to get students coding at a higher level like Java or Python, and really curious to hear your thoughts.
Like I said, I mean, in the classroom, I really do like Lego. And it's because not only can you build robots, but you can do science experiments, whether we're talking about biology or chemistry or physics. You can do all kinds of science with the Lego platform, in addition to all the engineering and technology things you can do. And when it comes to coding, yes, you can use the Lego Mindstorm language, which is a graphical drag and drop language. And I think for a introduction to coding, you really, particularly, almost at any age level, really starting out with the graphical coding languages is a great idea. But Lego, you can use dozens of different languages. And if you have Blockly, and Blockly is a great way to transition from Blockly to either Java or Python or any number of different languages. You've got the Legos, which is a great thing to do with the Lego. So really, that would be the top thing. With the Arduino, and again, it's open platform. I'd say probably the biggest thing there is how do you as a teacher feel with it. You're not going to have as much tech support. It's easier to break the things. It's pretty hard to break a Lego brick. Whereas an Arduino board, you drop it or someone steps on it, and you step on a Lego brick, nothing's going to happen. You step on an Arduino board, forget you're out the Arduino board. But if you're careful with the things, you can get into some. There's no limit to what you can do. You just got to be prepared that so there's no ceiling, but the entry level isn't quite as easy with that. Great.
Wonderful. Thank you very much, Gary. I think that's all the time we have today. So I want to thank you, Gary, and I want to thank everyone on the line with us here for attending this webinar and for submitting some really wonderful questions. I really hope that you enjoyed this session and really hope to see you again soon. We will share a recording of this webinar and Gary's presentation slides with everyone in a follow-up email. And I was chatting with a few people privately on a few specific questions. I'll make sure to follow up with each of you as well. So thank you very much. I do also want to take a few seconds to announce that our next STEM education webinar is entitled, Is Blockly the Next Big Thing for Robotics Education? And that will be held on May 16th. Our speaker here will be Ken Gracie, the CEO of Parallax. You can visit gocoderzee.com/webinars to learn more about this session and register. So if anyone is interested there, please go to that website and take a look. We also invite you to keep the conversation going with us on our ever-growing Facebook STEM group, where we have hundreds of STEM teachers and leaders who have already joined and are already conversing with each other. You can find it on Facebook's group page by searching for the group Robotics and STEM for All, or you can enter the URL www.facebook.com/groups/STEM, the number 4, and the word all. And then finally, if you're interested in learning more about Intellitek's Coder-Z platform or about coding virtual robots, please find us on www.gocoderz.com. And actually, if you visit that website, you can actually sign up for a free 14-day trial of our Coder-Z program and actually get a chance to try it for yourself. We also offer public demos as well as some virtual walkthroughs if you need it, and we would really love to hear from you. So once again, thank you all for joining us today. I hope you all have a wonderful night. Goodbye.